projects in energy. It's a pleasure having Tom Kirkman today. Tom is an experienced project manager and PMO consultant in oil and gas, renewables, and heavy industry nowadays. Good morning, Tom.
How you doing? Nice to talk to you again, Armando.
It's a pleasure. Tom, please tell us, projects, design, construction, etc., are different in oil and gas compared to renewables. What are the main difference between these two fields?
There's quite a number of differences. One, oil and gas is typically more complex and more large engineering is involved. Renewables are typically less complicated. So you've still got mechanical structures, you're still managing energy, but oil and gas is far more complicated and involves many, many more disciplines than either solar or hydro or wind.
You mean because you have more equipment, more systems, more controls?
Yes.
You
don't have, for example, compressors or pumps or any of that stuff in a solar power project. You basically got a whole bunch of solar power projects bolted onto a metal rack, and it's not really that complicated. It's not rocket science. Whereas an offshore oil platform, my experience is mostly offshore oil and gas. I was in Asia for 20 years and primarily dealt with offshore oil and gas platforms. So
dangerous fluids, CO2.
Yes, H2S, all sorts of stuff. So a solar power project. I did one solar power project when I arrived here back in the US from Asia, and that was putting in 20,000 solar panels in a field in the middle of nowhere in the Upper Peninsula of Michigan. So at its peak, we had about 60 guys on site. When it got really, really hectic, we had about half electrical engineers. We had to use union labor because we ran out of experienced electricians. And then the other half is just totally inexperienced people. Basically, all we look for is, look, this is hard physical labor and you're going to be out here, slugging the stuff around. Whereas oil and gas projects, there's a far higher percentage of very highly skilled technical labor. You need that technical expertise because there's so many disciplines. For solar power, it's primarily on the engineering design, which is going to be a lot of copy and paste. And then electrical, well, really the electrical, solar power projects are not that complicated. So once you come up with the basic pattern, there's just basically variations on the theme, whereas an offshore oil platform has so many disciplines: piping, valves, compressors, filters, all sorts of stuff. But I will say this: when I approached the solar power project, when I was there on site for 4 months from beginning to end, and the way I wrapped my head around it, because I'd never done a solar power project before, but I've done project management for a long time, is the basic concepts between the overarching, 40,000 foot view between a solar power project and an offshore oil platform are very similar. Is if you look at it from the energy point of view. So on an offshore oil platform, you'll have a structure, the main structure, and down below you'll have all these feeders. You'll have a dozen or two wells that are basically poking holes in the ground with pipes to gather up the energy. The energy, oil or gas or both, get gathered into a central processing platform, a central processing point, and you filter it out. So you separate out the oil from the gas, from the water, from the sand, and then you do some basic processing before it gets shipped either via pipeline to shore or further out to a floating
shuttle
tanker where it gets stored. So if you just bear in mind that basic idea, now a solar power project, you've got at the heart of it is a central electrical power processing facility. And you've got all of these solar power panels that are individually gathering up solar energy in DC form. And at the end of each row, there's a junction box which compiles things together, and all of those junction boxes together go to the central processing area where the DC electricity is cleaned up and converted to AC energy. So you're processing the energy, and then it gets hooked into the grid, which is typically going to be close by, and there's like a regional area where the energy gets sent to. So the overarching idea is gathering, filtering, and purifying, converting it into a more useful area, and then moving it along into the larger energy structure. It's not that different.
Yeah, it's much easier than oil and gas, of course. But let me ask you about time. How long takes a construction of a solar or a wind system? Because in oil and gas offshore, it takes 3-5 years, depending on the complexity of the system.
Easily, offshore oil and gas is far more complicated because for the simple reason that you've got so many different disciplines, mostly mechanical, but there's just so many different disciplines. I can't talk too much about wind because I've never done a wind project, but I can talk about solar. And again, solar is not that complicated. It doesn't take that long. It depends on the size and scale of it, but that's about the only complexity. Whether you're doing a small field or some of these mega projects are enormous, but they all follow the same basic process. And it's just a copy and paste of row upon row upon row. And they're all collecting up the energy and funneling it toward an electrical central processing area to convert it from DC to AC and stabilize the energy flow. You got to have a buffer. In the same way, you've got a choke valve on offshore oil platforms to smooth out that fluctuating high pressure flow, and you put it into a usable format that doesn't cause all sorts of havoc in the pipelines up above. Solar power is intermittent. It can have huge spikes and drops. So you've got to basically have electrical design in there to put it into a more useful format that doesn't have extreme pipe, surges and drops. You want to level it out as much as possible. And I'm not an electrician, so I can't explain the details to you, but that's the general idea.
Yeah. And the source of funding, I mean, the origin of money to apply, to invest. For oil and gas, normally the big ones have their own money from portfolio, and in this case, come from banks or for financing systems. How does it work?
It's totally different viewpoint, and this is why I was laughing, between oil and gas, which tends to be more along the lines of self-funding or for large project bank loans, but with they've done this before repeatedly, whereas solar power is a little bit, large solar power projects are a little bit newer, and their primary focus is getting tax rebates. So in the United States, generally, and I'm not an expert on this, but I know when I was around doing this particular solar power, it started off a number of years ago where there was a 20% tax rebate and 2% was knocked off each calendar year. So the big deadline is always going to be before December 31st in the United States, because you want that extra 2% of that tax rebate. So if you're talking a $20 million project, 2% is a sizable chunk of money. And if it goes one day over that date of getting electrons into the grid after December 31st, you've just lost a whole bunch of money. So it can be self-funded for a larger company, or they can get bank loans. But on the other hand, oil and gas projects are far more expensive.
Sure.
Same with LNG. Same as natural gas. Fracking is a different beast, and I don't really want to comment about fracking because I've never been involved in fracking. Honestly, I'm not a real big fan of fracking. I don't like what it does to the environment, but it's like, my view is every source of energy is a useful source of energy, even if it's intermittent or whatever. We need everything we can get. But there's no comparison between funding for oil and gas and LNG projects. LNG projects used to take about 7 years. Now they're down to about 5 years, and I think for floating offshore about 3 years or something like that. So it's improving. But solar power and again, I can't realistically comment about wind, but wind may take a little bit longer because you've got more fabrication to do with materials. But solar panels are fairly simple. You erect a metal grid, pound the posts in the ground, attach the metal grid, and you attach the solar power panels, hook up the wires, and you're off to the races.
Yeah. You mentioned LNG. Let's give the idea to Canada to install some LNG
they won't,
export
because
to Europe.
true to know. This is very, very frustrating to me. Canada could be a huge source of LNG for rescuing Europe, but the current prime minister, whose name I'm not going to say, refuses. He flat out refuses, and instead he wants to use hydrogen, which is in my view, the absolute wrong move. You waste huge amounts of energy producing hydrogen. There is a huge waste. Also, storing hydrogen, because the molecules are so small, is a horrible task. And it also hurts just about any metal it comes into. It is really, really hard to use. It is very inefficient.
By corrosion?
And yes, corrosion. You've got stress corrosion cracking in certain metals just because hydrogen brittlement. It's hard on metals. It's just not good. You're going to have hydrogen leakage. Hydrogen is just really, really messy. But my main concern is it's so inefficient to generate hydrogen that what is the point? So if most hydrogen is going to be generated from natural gas, why not just use natural gas?
Yeah, directly. Yeah.
The world is set up for natural gas. It's not set up for hydrogen. So this huge push for hydrogen, I would have to ask, it's like, okay, who's going to benefit economically from moving away from a naturally occurring resource, which is all over the planet, which is natural gas, and also what they call renewable natural gas, which is basically natural gas from, garbage dumps and all that other stuff. But natural gas is naturally occurring. You can't just set up a hydrogen sucker-upper in the atmosphere and just suck up hydrogen like you can suck up efficient natural gas to hydrogen, in my opinion. Unless someone can convince me otherwise, it's like it seems more straightforward to simply use natural gas. Just my opinion.
Yeah, interesting. To go to the last point that I'm very curious about your opinion. What are the additional requirements for a professional that works for oil and gas industry to move to the renewables industry? What are the requirements?
It's hard for me to say that. There can be a transition. One, the pay is going to be lower. Two, you're a technical expert or a specific engineer in the field of oil and gas won't be able to use that particular field anymore, although they can use their background and adapt it to the engineering requirements for renewables. But the thing is, honestly, the engineering requirements for renewable projects are not anywhere close to the standards for oil and gas. And oil and gas follows international standards. ASME, ANSI, American Society of Mechanical Engineers, American National Standards Institute, API, American Petroleum Institute, BS, British standards. There's all these global standards around the world where if you go to any oil and gas installation anywhere in the world, they're all using basically the same specs. There can be a different pleasure between the American version API and British version, British standards. There's also on ships, there's the JS, Japanese standard, but that's only for Japan. Whereas renewables, a lot of it, they don't have a lot of standards. There's minimal amounts of standards.
ASME, for instance, is one of the standards that
American Society of Mechanical Engineers. So that would be, for example, if you want to use stainless steel, there's certain standards that you must meet in order to comply with the international standards. So, for example, bolt sizes or flange sizes, they're the same anywhere you go, anywhere in the world.
Same.
Flange sizes are standardized, whereas in electrical for solar power, there are some basic standards, but a lot of it is left open, and a professional engineer has to basically certify that the design that they've invented is going to work. It's not nearly as organized and what's the word I'm looking for? Institutionalized as the mechanical standards for oil and gas industry. I'm guessing, this is just a guess, I'm guessing the standards used for solar power projects in Asia and Europe and North America are probably a little bit different. You don't have the exact same international standards that everyone uses. That's just my guess, though, because I've seen a lack of overarching massive amounts of technical specifications for these.
Perfect. Have a good Sunday. And thank you so much for this nice conversation.
It's been a pleasure talking with you as always, Armando. Take care. Have a good weekend.
You too. Bye-bye.